So in this video we are going to take a look at finding the inverse Z transform. Okay, and as always the first one, we are just going to take a very complicated example, then later on you can build from there. So let's assume you have this question. In the question you have a function h of z, which is given as a function with a numerator z of z plus 2, and the denominator is given as z minus 0.2 multiplying z plus 0.6. Now you are asked to find the inverse Z transform, okay? And one thing you have to first try to do when you have something like this, as much as possible, express it in terms of Z minus, okay? So you realize that we have Z with the positive powers. You have to express it in Z with the negative powers, okay? So what I would do is just first divide numerator and denominator by Z squared, okay? So divide by Z squared. Z squared. Now we'll go quick. When you divide the numerator by Z squared, okay, you get 1 plus 0. Oh, sorry, it is 2. So 2 Z minus. Hope that works. And when you divide the denominator by Z squared, now it is when you divide the denominator by Z squared, it's like you are dividing here by Z and here by Z. Okay, because Z times Z will give you Z squared. Okay, so when I divide this one alone by Z, I get what? 1 minus 0.2 Z minus 1 times, divide this one alone by Z, I get 1 plus 0.6 Z minus 1 as well. Right, so now we have a beautiful expression in terms of Z, and we can go ahead and find our Z transform. Now, the issue is we don't have any known formula for the Z transform of something like this, okay? Because usually the Z transforms you have are the Z transform for functions like delta of n, for functions like u of n, right? And for functions like the cosine and sines, right? Those ones are common, but this one doesn't look like any of them, right? And we know that the Z transform for the delta of n is 1. For u of n, usually most book give it as right. Yes. So it means that we have to go ahead and express this in a form which we can handle, either some form like this or this. So what we do is that, then let's go ahead and express it in terms of partial fractions. Okay, since we don't have any way to go about it. So when you try to express this in partial fraction, I mean, it's just your previous partial fraction knowledge. This one in partial fraction is the same as a over, let's do the first one, minus 0.2 z minus 1 plus b over, the second one is also what? 0.1 plus 0.6 z minus 1. Okay, so yes, if expressed in terms of partial fractions, then now we have to find a and b. Okay, so we can simply say, so that one, I mean, you can go through various ways, okay, but I mean, there's a short way. So you can say a is equal to h of z multiplying the denominator of a, which is what? 1 minus 0.2 z minus 1, right? Given that 0.2 z minus 1 equals to 1. Do you get it? What you are saying is that, I mean, if this one goes to 1, right, the whole denominator goes to 0, right? And if that goes to 0, then it means that we are only finding a. I mean, it's just knowledge from partial fraction being used. So we are assuming that 0.2 z minus 1 is equal to 1 so that we can find a. Now, you come and check your function h of z, right? You realize that h of z, when multiplied by this denominator, 1 minus 0.2 z, you only get what? The top, which is 1 plus 2 z minus 1, all over what? 1 plus 0.6 z minus 1, right? So we can say that a is now equal to the top 1 plus 2z minus 1 over 1 plus 0.6z minus 1. Okay, given that what 0.2z minus 1 equals to positive 1, right? Then now we can solve, right? So in the solving, we are saying that 0.2z minus 1 equals to positive 1. So it means that when we have 2z, that will be 10 times the value. You understand? So it means that here will be 10, right? Because, I mean, 2 divided by 10 is 0.2, right? So if 0.2z is equal to 1, then it means that 2z is equal to what? 10, right? This is just implication. So it means that A will now be equal to 1 plus the numerator 10 over the denominator. Well, we have 0.2z, but we want 0.6z, right? That means we have to multiply both sides by 3. Multiply 0.2 by 3, get 6. Multiply 1 by 3, get what? Multiply 0.2 by 3, get 0.6. You multiply 1 by 3, get what? 3 here. So the denominator will be just what? 1 plus 3. And our answer will be what? 11 over, I think, 4. And this, I think, is just 2.75. Okay? So we are done with A. Then we go and find for B. So B is also the same procedure. So B will just what? H of Z, right? Times what was the denominator of Z and B? B was what? 1 plus 0.6Z minus 1. So 1 plus 0.6Z minus 1. Given that 0.6Z minus 1 equals to minus 1. Okay, because that's the only way this thing here will go to 0. Then we solve. Right. How do we solve this? Yes. So, I mean, when we multiply h of z, this h of z by 1 plus 0.6z minus 1, we'll be left with only this one and this one. The top 1 plus 2z minus 1, and the denominator 1 minus 0.2z minus 1. Okay. So, we'll be left with the top 1 plus 2z minus 1, and the denominator 1 minus 0.2z, or the denominator is 1 minus 0.2z minus 1. Yeah. 1 minus 0.2z minus 1. Okay, and now we are solving this, given that 0.6z minus 1 is equal to negative 1. All right, so we have to go to the next step. And the next step is we have to substitute this. So if you have 2z minus 1, but we know that 0.6z minus 1 is equal to minus 1, that means that 1 plus 2z minus 1 will be equal to what? Minus 2 over 0.6. Right? And I mean, you can try doing the substitution yourself. And 1 minus 0.2z. So here was 0.6, right? So it's equal to minus 1. So what will 0.2 be? 0.2 just be what? Minus 1 over 3. So 1 minus 1 over 3. Then I can point this with your calculator. So when you point this, I think you get something like minus 1.75. I'm sure. So minus 1.75. Okay. Yes, so we have been able to find B. We also found A. So we'll put it back into their original equation. So A was 2.75 over the original part of A was 1 minus 0.2 z minus 1. And B was minus 1.75. So minus 1.75 over the original part was 1 plus 0.6z minus 1. 1 plus 0.6z minus 1. Okay, so now this becomes our new h of z, which has been split in terms of partial fraction. Then you can go ahead and try solving. So, I mean, when you try solving, you have to find the inverse z transform. Okay, now I realize that this looks like a common expression, a common z transform. It looks like the u of n z transform. Okay, so we can say, well, 2.75 multiplying, right, it actually looks like the alpha u of n z transform. Okay, So, and that one is this as simple as this one. So you let me explain the alpha U of n z transform. So the alpha U of n z transform goes like this. When you have some number alpha U of n, and you are asked to find the z transform of this. The z transform is 1 over what? 1 minus alpha z minus 1. Okay, so that's how the z transform is. Usually they'll give you a table for this, so don't worry. But I just wanted you to see it. So it means that then that of 1 minus 0.2 z minus will just be 2.75 as the numerator, multiplying 1, multiplying 0.2 raised to the power n times u of n. Okay, and for this one, that will be let me write it down here. So for this one, that will be minus 1.75 times, I realized that when here was negative, we got a positive what alpha, so that here we get negative alpha, so I know 0.6 raised to the power n times u of n. Right, so we can write our total answer. Our total answer becomes 2.75 times 0.2 raised to the power n multiplying u of n minus 1.75 times minus 0.6 and multiplying u of n, and that becomes inverse z transform. Okay, so in as much as the steps are many, it's just splitting into partial fractions and using the identities. That's all for this video. Thank you.